This is the video submission of Team TwinSpace from the Georgia Institute of Technology's GVU Center. Our design employs a strong physical mapping using tangible objects and physical actions to interact with the supermarket model. Navigation and selection takes place using the TwinSpace trolley, which is a physical proxy for a shopping cart in the virtual world. Orientation of objects on the table is accomplished using physical tokens placed on a tangible tracking table. Their manipulation is mapped to movements in the virtual world. We will now demonstrate how these components work together by going through the task. Users navigate the virtual world by pushing the TwinSpace trolley through the physical space. The movement of the trolley is mapped to the movement in the virtual world. As users maneuver through the aisles, they will find and select the items that they desire. A touchscreen pen is used for selection of items. This includes the first and second items. Users further navigate in search of desired items. Once the third item is selected, users will move to the tabletop display. In the virtual world, each of the three items can be seen inside the shopping cart. Once the interactive tabletop is reached, the user will place the items on it in any order. Once on the table, the items can be moved in any position and any orientation.
Now begins technical explanation of our demonstration. The tangible tracking table is an interactive tabletop display that uses computer vision to capture user and object movements on the tabletop. A projector and two mirrors create a 6-foot projection distance and a 55-inch image. To track objects on the tabletop, we use unique fiducial markers attached to the underside of the objects. The table is able to capture the movements and rotations of up to 180 objects simultaneously. In this case, the location of the table in the physical space is mapped to the location of the purple table in the supermarket, and the table's display shows the virtual tabletop. We use several physical objects as proxies for store items selected using the trolley. When an item is selected, its ID is associated with one of the proxy objects. When this object is placed on the table, it is moved from the shopping cart onto the purple table immediately, manipulating the physical object on the table causes the mapped item to be manipulated in the virtual world. The TwinSpace trolley is an interactive kiosk that maps movement through physical space to movement through a virtual world. This is accomplished via sensor assembly that provides data reckoning, orientation sensing, and dynamic calibration with a virtual world layout. A floor tracking optical mouse is attached to the bottom of the trolley. The mouse detects movement as the trolley is pushed around the room. We advertise these movement events using a room-based messaging server. In this case, the virtual world client on the trolley captures these events and converts them into corresponding movements in the virtual world. A motion node 3D orientation sensor is attached to the far side of the trolley. We report rotation about the horizontal plane via the room-based messaging server. The virtual world client captures these events, also converting them into rotations in the virtual world. The mouse movement data accumulates error over time. As a result, it is difficult to precisely map traversal of our physical room to movement through the supermarket. Periodic synchronization between physical and virtual locations allows locations in the physical room to map to locations in the virtual world. We accomplish this using a grid of RFID tags affixed to carpet tiles in the TwinSpace room. An RFID reader is attached to the bottom of the trolley. When the trolley rolls over a tag, the value is converted into its coordinates in the physical room, which are then converted into mapped virtual world coordinates. The trolley captures these coordinates and calibrates its position in the supermarket accordingly. By combining the abilities of the TwinSpace trolley, interactive tabletop, and room sensors, our design allows users to effectively maneuver and manipulate objects in the virtual supermarket space. Once these objects are retrieved, their manipulation in virtual space is as intuitive as manipulating them physically. By emphasizing the advantages of direct manipulation, our design aims to make the completion of the task an efficient process.